Hello, my name is Charlton Chong, and today in this video I'm gonna talk about how to make pivot tables and also graph for our group assignment. So first, as you guys can see from the screen, there's our data for our group. First we go insert pivot table, and then we select all the data from the top until the very bottom, which is here. Okay, new worksheet, click OK. After that, in this new table, on the right hand side we can see there's weight, relative density, tensile strength, and also shift. So in our group, we choose the shift as our row labels. So we can see evening, morning, and night. And also we click weight and then add to value. So it will sum it up, become sum of the weight. This one is for the evening, this one is for the morning, and this one is for the night. This one is for the grand total. So we do the same thing for relative density, add to values, tensile strength, add to values. So this is how we make the pivot tables. So right now we have to make the graph. So we have to highlight everything, insert, chart. So in our group we use pie chart and also clustered column. So first we go to pie chart, click the pie chart, and there we have it for the pie chart graph. And then we highlight again, insert, chart for clustered column. So this is our clustered column graph. So for more detailed information, we can click this one, right click, add data to labels. So this one is the labels. Same goes to the clustered column. Okay. So there you have it. This is our pivot tables and also graph for our group assignment.
Hello, my name is Brandon Frederick, and I will describe and summarize the simple data of our assigned Lajak Laku tablet, which is tablet B, produced in January 2020. So from the data given, 200 sample data were collected from 3 different production shifts, which is the morning, evening, and night shift. And the data collected were the weight, relative density, and the tensile strength of the tablet. So from the data given, it is very mixed and random, and it's very hard for us to understand and analyze. So we summarize the data into tabular and graphical form. So from the tabular table, we already calculate the weight, the relative density, and the tensile strength from 3 different production shifts, which is in the night, morning, and evening shift. And from the tabular table, we can see that there is only a slight difference of value for each category of the data. And then from the tabular data, from the tabular table, we also calculate the grand total for each of the category, which the weight, the relative density, and the tensile strength of the tablet. And next we proceed to the graphical method. So we already summarized the data in graphical form. So from the bar chart here, we can see that the production is at the maximum during the morning shift. The morning shift produced the maximum value for weight, relative density, and tensile strength. And we can also see from the bar chart here that the production is very least or minimum during the night shift, which is during the night shift the weight and the relative density and with the tensile strength is very minimum. So we can summarize that the production is at the maximum during the morning shift, and the production is very minimum during the night shift.
Now, I would like to comment on whether there is significant evidence that the weights of standard tablets produced by the manufacturer is normally distributed with 350 mg with standard deviation of 40 mg. Firstly, we need to find out that the probability of each interval by using the formula of normally distribution, z equal to x minus mu divided by sigma. Then, find the probability from the statistical table tree. Next, we do the hypothesis and set the hash note as the weights of standard tablets produced by the manufacturers follows normally distributed with 350 mg with standard deviation of 14 mg, while the hash 1 do not follow the normally distributed with 350 mg with standard deviation of 14 mg. For the test statistics, we will construct one more table and data with OI, P, EI, and OI minus EI squared divided by EI. Since the EI of weight between 300 and 320 is 4 below 5, the EI need to combine with the next groups until the EI is more than 5. This situation is also applied in the weights that more than 380 mg. We will then use the OI and EI to find the final value of OI minus EI squared divided by EI, which is also equal to the critical point x squared test. For the decision rule, we set the alpha as 0.05 while the degree of freedom V is equal to 2. From chi-squared distribution in the statistical table, we can find out that the x squared 0.05, 2 is equal to 5.9915. Thus, we will reject hash naught if x squared test is greater than the hash naught. Lastly, since our result x squared test is equal to 1.3797, which is smaller than the 5.9915, thus we fail to reject hash naught. So we can conclude that the weights of standard tablets produced by the manufacturers follows normally distributed with 350 mg with standard deviation of 14 mg.
Now, I would like to explain about how to comment whether there is a significant difference between the tablet weights for the three different shifts, which are morning, evening, and night shift, by using ANOVA method. First of all, we divided the given data according to their respective shift. Then, we analyze the data by using the Excel, and these two tables will come out. Next, we do a hypothesis. We set hash naught as mu1 equal to mu2 and also equal to mu3, while hash 1 we set as mu I not equal to mu j for at least one I and j. Then we do an assumption that each sample is drawn from the normal population with the same variance. From the table, we can see that the value used to measure the overall variability is equal to 39,351.81, and the value used to measure the variability due to treatment effect is 168.4773. The suitable decision rule that we have made is based on p-value. If the p-value is smaller than the alpha value, this means that we will reject hash naught. We assume the alpha value as 0.05. From the table, we can see that the p-value is 0.6553, which is greater than the alpha value. This means that hash naught will fail to reject. Therefore, we can conclude that there is no significant difference between the tablet weights for the three different shifts.
Assalamualaikum and hi. I'm Hani Mafiz. I'm going to explain about the simple linear regression analysis. Let's really analyze the summary outputs. The regression statistic, we have the multiple R, 0.840, and the R square. Like before this, we found right here, it based on this. As we can see, it's the same value. We have the adjust R square and the standard error. Standard, it means the standard deviation from the data, and the observation. We have 200. It means that the n that we have is equal to 200. Okay. Let's see again about the R square. It's 0.7068. It means that the 70.68% of the variability in tensile strength Y is explained by the regression line. We move to the next table, which is the ANOVA. What we have here is the regression, residual, and total, and DF, the degree of freedom, summation of square, MS means square. We got the F value and the P value right here. 1 here is mean the K is 1. So as we can see right here, the P value, significant F, is 0. So it means that the probability for something to occur from this data is very low. And then we move to the next table, which is have the intercept and the relative density. So the coefficient is negative 0.1725 and 0.0826. And this part we can see the equation before this right here. From this we can build this equation, and we have the standard deviation from that, and the t statistic, and the p-value for the lower and upper is 95%. Let's we see the residual output. This is the residual. It means something that the error from this data